Yes, dear students, now in this video I am going to tell you how the viscosity is to be measured and heading is coefficient of viscosity. I told you viscosity is a kind of force of friction between two layers of liquid which oppose the relative motion. Now listen patiently, this is not easy to understand. Here it is a plane surface, not a line, like the floor of room or floor of any river or any canal. It is not a line, it is a surface on which liquid is flowing. The layer of liquid close to the surface is at rest almost, and as we move the velocity keep on increasing. The topmost layer R, PQR, I have shown three layers which are at distance. This is at x, this is x minus delta x, this is at x plus delta x. ये distance increase हो रहा है, तो velocity also increasing. So what is seen here? A liquid is flowing on a plane surface which is at rest. The layer close to the surface in touch of this solid surface is at rest, and velocity of different layers is moving, and this flow is said to be laminar flow, or you can other way you can say streamline flow. Actually, in streamline flow, velocity at any point does not change with time. So in a layer, all particles of liquid will have same velocity. So what is there? Now listen one thing more. So the lower layer P then Q has lower velocity than this. So P layer try to decrease the velocity V of layer Q, while layer R has more velocity, and so it tries to move forward. Layer R tries to increase the velocity V. So this layer Q, every layer in fact, not only Q, experiences a net retarding force. Net retarding force due to viscosity. If you want to maintain the speed constant, then you need to apply an external force which is equal in magnitude to the viscous force. So that force will, otherwise it will stop. You might have seen when any liquid flows on surface, that stops after certain, but if you want to make the flow constant, then you have to apply external force. The water in river or canal flows because of slope. There is slope, and a component of it applies a net force. So liquid also, if no external force applied, will not flow. Actually, liquid or fluid flows due to pressure difference, and pressure equal to force upon area. So some external force are always required to make the flow steady. So let in figure a liquid is flowing on a solid surface. The layer of liquid in contact with solid surface is at rest. Velocities of different layers increases with the increase of distance of layer from the surface at rest, from the solid surface. हाँ भाई, तो velocity keep on increasing. Here layers P, Q, R are at distances x minus delta x, x and x plus delta x respectively. And have velocities v minus delta v, comma v and v plus delta v. यानी कि वेलोसिटी ऑफ लेयर P is v minus delta v, Q v plus v and that of R, or you can write here also respectively. Here, due to viscosity, lower layer tries to retard the motion of upper layer, while upper layer tries to accelerate the velocity of lower layer. As a result of this, a net retarding viscous force, act on every layer. So, to maintain the velocities of liquid layers same, means if it has v minus v, so it should remain v minus v. If it is v, it is equal to, it should remain v, and so on. We need to apply an external force which is equal to the net retarding viscous force, net, which is equal to the retarding viscous force. Why I am telling equal to? If there is net force, there will be acceleration, velocity will keep on increasing. You know from Newton's cycle law, F is equal to ma. If there is net force acceleration there, then velocity every layer will start increasing. So to maintain the flow streamline, or laminar, we need to apply a force which is equal to viscous force. Here the change in velocity of different layers per unit distance between them, that is delta V upon delta x, is called velocity gradient. Actually, to understand viscosity, we need a long introduction, not a long description. By this velocity v minus delta v, it is v, तो change हो गया delta v बढ़ गई, इसकी ओर बढ़ गई, and then delta v upon delta x called velocity gradient. Up now we come to the point here. Newton found that to maintain the flow streamline, streamline is velocity of molecules in these layers does not change. In this layer, it is v plus delta v, remain v plus delta v. It remain v, it is v. That's all. Streamline or laminar, you can say laminar. A net, laminar flow. The external force per unit area of layers is proportional to the velocity gradient between the two adjacent layers. Mathematically, we can write Kf is equal to force per unit area F upon A. Actually, this defines also pressure difference between the two. F upon area. अगर ये पॉइंट हम यहाँ लेते हैं तो इनके बीच का प्रेशर डिफरेंस बताएगा वो. नेट फोर्स प्रोपोर्शनल टू डेल्टा V अपॉन डेल्टा x. और F upon A equal to eta. This is spoken as eta. delta V upon delta x. Here eta is constant of proportionality and is called coefficient of viscosity, or simply viscosity. Actually, here point is that we have to explain each and everything. In exam you get short questions, and question may be from all this text which I have written. So here we want to know what is eta. So eta is equal to F upon A into delta V upon delta x. I told you delta V upon delta x is velocity gradient. By measuring eta, we are able to measure viscosity of the liquid or gas, जो भी हम नापेंगे. अभी तो what is this? If delta V upon delta x is 1 unit of velocity gradient, then eta is equal to F upon A. Dear students, this is eta. In class 11 NCERT book, we are given the symbol and their sounds on the last page. Please verify. I have seen people speaking it as neta. This is not neta. This is neta. It is also simply alphabet. Letter saying sorry. Now what is eta then? Therefore, coefficient of viscosity is numerically equal to a net force per unit area which is required to maintain unit velocity gradient. Gradient between coefficient of viscosity numerically equal to the net force per unit surface per unit area which is required to maintain unit velocity gradient between the two layers. Please listen what I am telling. Force applied from outside. Now, only to maintain the flow constant. If you will not apply external force, then flow will stop because of viscosity. As I told you, when you take water in a tumbler or glass of water and rotate that by a rod, and now after some time you stop stirring. For some time water keep on moving, but after a while it will stop. So that way that force is required, and that force per unit area which is required to maintain unit velocity gradient is called viscosity. SI unit of viscosity is poisoly, बड़ी खराब स्पेलिंग है, POISEUILLY, पोइजली, जिसको लिखते हैं PL, सॉरी कैपिटल PL, और they write here many other units like देखो ना, eta equal to F upon A into delta V upon delta X. तो फोर्सिंग डिस्टेंस, ये प्रेशर हो गया पास्कल है भाई, पास्कल पर सेकेंड, यहां से पर सेकेंड पास्कल सेकेंड, और पास्कल सेकेंड, और दे राइट हियर आल्सो है न्यूटन सेकेंड पर मीटर स्क्वायर, न्यूटन सेकेंड पर मीटर स्क्वायर. But in one book it is also written as poise. एक इन्होंने poise भी लिखा है, poise. One poise unit equal to 1 kg meter. नहीं, 10 poise actually. 10 poise equal to 1 kg per meter per second. Dimensional formula for viscosity is ml minus 1 t minus 1. We are given a table here in which viscosity of different liquids are given. You can see table 10.2 here. Viscosity of water 20 degrees centigrade is 1.0 millipl. And that of glycerine 830 millipoisoly. So then glycerine has nearly 830 times larger viscosity than water. Honey has 200. Air 0.017. प्लीज ये चीज़ें भी नोट किया करो. Use this table to read, है ना? This will help you to understand. If you don't know what is your height or what is your weight, it means you are not aware of yourself. When we are studying science and physics and we are studying viscosity and we don't have any idea of the ratio of viscosity of water and glycerine, it means we have not studied. We were just passing in the time in the class. So I hope you have got my point, and please work hard and please share the video and ask your friend to subscribe me. My video, I'm in class 11 to listen there. One thing more, I'm observing that simple topics are viewed by students very much, but the harder one are not viewed. I gave some questions of class 12, very few viewers are there, and I explained you this viscosity in the morning. A lot of viewers are there, but we have to see everything in exam. Actually, जो competitive exam है, जो the student who are preparing for AIEEE or JEE or NEET, they have to face difficult questions. Without doing them, you can't compete any exam. Those things are simple, but fundamental topics are used.